Dan wil ik nog de Mobiliteitsfabriek hartelijk bedanken voor het sponsoren van de locatie. Dat is best een applausje waard. En The Usual, Server Grove, Ingewikkeld en O'Reilly ook voor hun bijdrage. Daarnaast wil ik ook Paul hartelijk bedanken voor het filmen. Dat heeft hij volgens mij de afgelopen 3 meetups gedaan. Weet ik niet helemaal zeker. Maar we zijn je erg dankbaar daarvoor. En dat is super gaaf. Dus jullie kunnen deze talks ook op YouTube gaan verwachten. Maar we gaan nu eerst beginnen met Dennis de Greef, die ons gaat vertellen over Measuring Maintainability, Software Metrics Explained. Dus een daverend applaus alstublieft.
Welcome everybody, and congratulations to PHP Amersfoort with a 2-year anniversary. I'm going to talk tonight about a subject which can be beneficial for you as a programmer to know about. It's not necessarily something you would use every day constantly, but it's a good concept to be familiar with. I am Dennis de Greef. I am, among these things, mainly a software developer as a job at TransIP. And I'm interested in technology. That basically sums the parts. I have a small roadmap. I'm going to talk about software analysis, measuring lines of code, complexity, and coupling. But first, something about it. Software statistics are actually a scientific thing that was being developed when software development was more in the earlier parts, from the 70s till some parts in the 90s. But since it's pretty much scientific, all you can find about it online are formulas or begrippen. I'll subtitle that. Yeah, this will. Terms. And I've had lessons about these concepts, and I will explain them to you this evening in a more simpler way, I hope. So we can measure lines of code. I don't know if you know PHP CEO on Twitter, but make some.
It's my boss.
Yeah. So measuring lines of code. Can anybody tell me how many lines of code this is? 7. 6? 5?
4.
And this?
1.
Yeah, well, it pretty much depends on your definition. What do we mean when you have a line of code? I think you know this one, but for a definition, you have a few different types. You have more, but these are the basic ones for lines of code. You have physical lines of code, namely the 7 in the first example. Logical lines of code, those were well, actually, the PHP open tag in PHP is also counted. You could say so. And then you have comment lines of code and non-comment lines of code. And they can tell you something about your application. In this case, it's 7 physical lines of code, 3 logical lines of code, namely the printf, the for statement, and the PHP opening tag. Since these statistics were made originally for languages like Java, for example, you don't have an opening tag for that. So they were based upon that, but could be applied in any language. And there's a tool that can measure these amount of lines of code. I will mention it later, and it does include the PHP open tag as a logical line of code. So I'm taking that as an example. I'm not sure about the definition, but I'll go with it. So this is 6 physical lines of code and 3 logical. Because the for loop and the print statement are on the same line, you could write complete PHP applications on one line. But they have different logical things wrapped around them. So they are 3 logical lines of code, 3 lines of comment, and 3 non-comment lines, including the white space. So I've gathered some statistics from famous, packages I thought were mainly used. And what you can see here is, yeah, they're pretty big projects, some bigger than the other. But what interested me was the amounts of comments percentage per project, because that can say something about your code. It doesn't necessarily say anything per se, because it really depends on how well you know your code environment. I mean, if you have 80% of your lines are comments, that can mean two things. Either it's extremely well documented, or or it's extremely complex and needs the documentation. So it really depends on the application what these numbers say. Nevertheless, they can, if you know your application well enough, they can mean a lot to you. And I've put the PSR2 standard next to it because I've looked it up. It depends on your coding standard if you put the curly brace on the newer line or on the same line, how these statistics would relate to each other, but they are all PSR2. So yeah, yay for standards. Yeah, and it's nice to see that it says something about your code. Side note, there was a bug in PHP LOC. That's why I'm using a specific revision. Making a talk like this makes you verify things, and there one or two commits earlier a bug snuck in, so it counted some forms of lines of comment as not comment, but anyway, there should be a new version out any day now or something. So keep that in mind if you're going home trying to install everything and looking at it. Take into account which version you have, or check the issues/release log. Yeah, but a big warning is that you shouldn't use these statistics to measure any form of quality or productivity. People have done that in the past, but the effect is people will just game the system. Like I said, I can just apply a different code style. Whew, I'm productive. So yeah, don't game the system. Just use them as insight to gain insight of your application. And I found a nice quote from Bill Gates. You never know quotes, but it said Bill Gates. Measuring programming process by lines of code is like measuring aircraft building progress by weight. I find it nice enough to put it in here to share that with you. So the package PHP LOC, you can compose to require it. You could also do it with --dev to only have it in your dev environment. But it prints out nice lists of all the lines of code, comments, logical lines of code. And even if you go further than the simple examples that I've had before, you have them per classes with average class length per functions, and there's a whole list of those, including combinations of metrics that I will explain later on this talk. You can have nice combinations of those that can say something about your code. So, measuring complexity. There are two things that I'd like to explain about those. And complexity and quality are strongly related. So you have the concept of cyclomatic complexity. And it's a quantitative measure of the number of linearly independent paths through a program's source code. Like I said, it's a bit of a scientific approach. The M is the complexity itself. E is the number of edges on the graph. If you view all functions and all code as a big scientific graph. Number of nodes and the number of connected components. So, yeah, many smart, much complexity. Simply put, it's counting decision trees. Basically, if you have a size of cyclomatic complexity, it's usually about the amount of function, for, while, if, and case statements within a method, within a class, within anything like that. So, this is an example. And I put the graph next to it. So if you have a function foo, it can go either directly to done, or it can go to the if A, then to the if B, and has all 3 different paths to being done. If you have 5 edges, namely the lines, and 4 nodes, and it's one hole, and you take the formula, you have the 5 edges minus the 4 nodes times the amount of compounds is a cyclomatic complexity of 3. And there's 1, 2, 3 function, if, case, etc. Statements in here. Same counts for this one, which is a bit more complex. So you have 2 paths going over there and 2 paths going from B back again. That's 8 edges, 7 nodes on 1 compound, but also a cyclomatic complexity of 3, because you still have 1 function and 2 if statements. The else statement is not counted for, because it is a certain flow you can always go through if you take 1 path through it. So, how many tests do we need for this? If we were to write tests for all the functionality? 3. Yeah, you can either test, it also still depends on your definition. Yeah, and the budget, of course. But to have complete branch coverage, you can call the function foo with either true, false, and with false, true. So it will either take that path and going through that way, or that path and going through that way. And when you call those 2 functions, every piece of code has been called at least once, which is 100% code coverage, according to the code coverage metrics that we usually have in the current projects. Or does it? What about if I want to run false, false, or true, true? Those are also two different kinds of paths the program can take. Of course, you could say, okay, all my logic is only inside the ifs. If it's outside the ifs, you could say there is no real logic being performed. But if you want to test all paths for potential bugs because the if statements influence each other, you should test all 4 paths. And that's like the example in the image over there. Those are the 2 main paths, and the dotted ones are the other ones that you have. I took this picture from a blog post from Derek Rithens. I've seen him last year on PHP Northwest. He was talking about debugging past, present, and future. And he also said he was working on a nice new feature in Xdebug, which is path coverage. And path coverage is in Xdebug 2.3.0, but unfortunately the PHP code coverage is not yet supported. And yeah, I was thinking about it. It's pretty complex to explain in a UI how all paths are triggered. You'd have to work with maybe different colors or something like that. So there comes mPath complexity. And mPath complexity is the complexity of a method, is the number of acyclic execution paths through that method. Yeah. Yeah. So, what it actually says, when I take the end path and I take the previous formula and I have the amount of nodes that I have in the graph, and I have the path coverage example from Xdebug, it says, okay, I take all the paths from all the nodes, and that's the metric that I'm measuring. So whenever I have false, false, true, false, false, true, and true, true, I have a cyclomatic complexity of 3, but an mPath complexity of 4, because I have 4 different possible paths through this whole code base. And if you take that into account, all the possible paths through a code base heen, npath is exponential. So your cyclomatic complexity could be a certain number. It's good to keep an eye on that because it can show you pieces that may need refactoring in your code. But npath complexity is even worse. Yeah, it's the number of unique paths in here. And for example, I found this piece of code. Wow. Yeah, and it goes on. You have this much output as a printf statement. And this is everything after the printf statement to fill that template.
It's about 60 lines of code.
Yeah, about 60 lines of code. But it's the half of it is things like this. It's not necessarily unreadable or not understandable, but it is kind of complex because if they would influence each other, you couldn't grasp it in your mind, what impact it will have, let alone write tests for every case. The npath complexity number of this method is actually, because I calculated it, and this is the biggest one I've seen yet.
Can you please say, what's the number?
Yeah, I will put it in the subtitles.
I think approximately 12 Googles.
Yeah, alphabets. Alphabets. Yeah, this is the message that PHP will print out, and it says, okay, the default configured npath complexity threshold is 200, which is their same default for npath complexity within a method or a function. So, yeah. That's why just changing a small thing, what could happen, could go terribly wrong. Because if you have a big, maybe a cyclomatic complexity of 10, the npath could be enormous, and you don't know which path is actually being used in your code flow, which you don't have a test for. Because usually, especially when you start out writing tests, you're usually only testing the happy path. You're not testing anything else that goes in. Well, if you take it strictly, which is completely non-productive, you would test every path, and that's where also kind of the things come from, like prevent using else statements or keep your code more compact, small methods, because you can test them individually without having a big complexity factor, and you can test smaller pieces more easily with less tests to test it in completeness. So, there's one more thing I want to talk about, and that's the measuring coupling. And Matthias Novak also has a talk about this, and a book, by the way, blog posts. And it's actually, if I have this piece of code, how many things does it depend on, and how many things depend on that piece of code. So it's the coupling between packages, and packages being either a namespace or a composer package. Traditionally, from the Java perspective, it's a namespace. And I've actually had a nice discussion, even still this afternoon, about if you could see a composer package as a real package for this metric. It made me think, because the original concept of Martin's metrics, which this metric is called, is based upon a namespace, and namespace are packages. So you could say, okay, I have a small package on Composer, which is only one namespace. But if the package that's using it is not in Composer, like maybe all the projects that we write for customers, you can't really determine it how responsible that package is. So it applies more on namespaces, and it can be indicative on packages, but I really have to think that through after my discussion of this afternoon. But it's nice to see nonetheless. So it can say the instability of a package is the resilience to change. It's a metric between 0 and 1, where 0 is completely completely stable. And you have the afferent and efferent coupling, and that's the amount of packages depending on this class, and the amount of packages that are dependencies of that class, or namespace for that matter. You can use it for both. So if I have a efferent coupling of 3 and a afferent coupling of 2, you could say, okay, the instability of this class or package is 0.6. And you can run these analyzers through your whole code, through subtitles. So, and they can give you a general statistic about it. It can say, okay, the instability is between these borders on these pieces of code. You might want to look into that on pulling that apart a bit more. So while they don't say everything, like all these metrics, they can be really insightful in how your code works. Same counts for abstractness, which is how abstract a package is with a ratio between 0 and 1, with 0 being concrete. So if you only have normal classes, the package is completely concrete. Whether on the other hand, if you have a package with only interfaces or abstract classes, it would be completely abstract. And that also can say something about how many other packages can use it, or it's resilient to change. If you change it, what will break inside everybody that is using it. And well, a famous example is that who here has come across in their code or has written somewhere in their lives a util clause? How many methods were in there approximately?
Too many.
Too many, yeah. Too many. Yeah, I've seen util classes with about 200 methods or something, and they're spread all across the code base. So they're really responsible. It's a really responsible class. You can't change any of the methods or the signatures or add an extra parameter without setting a default, without breaking everything else if you would want to change that. So what these metrics are actually for is keeping the balance between how many things use it and how many things is it dependent upon before it will grow out of proportion, like the empath complexity example. And PHP mess detector has a few default rules, like a cyclomatic complexity of 10, empath of 200. It can also measure things like excessive method length of 100, too many methods. You can configure them yourself. It's an XML document where you can set those things, plug them into your system. Yes?
Would you consider those defaults to be good defaults, or do you always change them yourself?
I use the defaults, but if I experience that in my code they exceed a certain limit, for example,
you just up the limit.
it depends. Famous IT answer. It depends. I can look into that code. It's just a warning sign. And sometimes I come across examples. For example, if I have this is a nice example. If you have mapping files that map from like YAML to XML to SQL, whatever, they usually contain a lot of if statements, case statements, so the cyclomatic complexity of those classes will be high. The question is, will it become a problem to maintain in the future? And that's always the barrier where you have to decide, okay, either I can fix this now, or I'll shove it over to the next person.
Technical debt.
Yeah. Technical debt. Yes. These tools are like their name, just tools. They can give you insight, but you still have to make those decisions yourself. And these are general upon your complete code base. But if you take a tool, I use Scrutinizer for an open source project, for example. You can ignore those issues for specific things if you know, okay, I'm doing this really on purpose. I know this is a warning. It's a good thing that you're warning me about this, but I am doing this on purpose, so you can ignore this issue for now. So it really depends on what kind of code you're dealing with.
Okay, thank you.
Yeah. Yeah, it can detect other things. It's really helpful to take a look around, and you can combine them all. I use Jenkins, for example, at work, and have a lot of tools built into it. You can put nice graphs into it, and you can say, okay, if the cyclomatic complexity goes above the 10 threshold, your build can break. You check in the logs, okay, what is exactly the problem, instead of having to run it every time yourself. And that's why you can also set these defaults, okay, what's good for my application. You can also run them, if you're dealing with legacy applications, you can run them to gain a lot of insight on your application, set the threshold at its current limit, and won't let it exceed it on everything else you're writing into it. And then just taking it steps down until it's a lot more loose. So it can be a great tool for that aspect as well. So, any questions? Yeah?
Can you go back to the slides with graphs?
Yeah?
Which one?
Yeah, which one?
With the cyclomatic complexity, yeah.
Or the empath?
The cyclomatic complexity.
Yeah?
You're talking about compounds. What
Yeah.
are compounds?
Yeah, that's different endpoints. For example, if you have earlier return statements, it's in this function, it will always end here. And I can have, if I draw them out in a graph, I can have different endpoints. And yeah, I should have explained that, I'm sorry. That will determine on the cyclomatic complexity, how many empaths you have, and that you can multiply by 2.
Thank you.
Yeah, you're welcome.
So if you would...
Yeah.
So if you would have a return statement after the second if, that
Yeah.
would be 2 compounds.
Um,
Or sorry, inside
Yeah.
the first if,
yeah.
if you would have a return statement there,
Mhm.
like say in the else,
Mhm.
you would have 2 compounds. Or
Now
not?
you're making me doubt, but as far as I remember
it's
from
a question,
everything that I've used, yes,
Okay.
but not yeah, yeah.
Okay.
I'm 99% sure. Yes.
I will trust you on that.
I'm sorry. This is the first time I'm
No,
doing
no,
this
it's
talk. I
okay.
will-
99% is good enough.
Yeah. Any other questions?
Yeah.
Have you ever used a method of visualizing this kind of complexity or the choice paths within code? So the graph that is shown here,
Yeah.
if you could apply it to a piece of code, then it could be really insightful of
Mhm.
how the program actually works.
Yeah. It does. I have done another talk in the past about profiling, and then you have a call graph which can show you every point which your code goes through, which allows for that kind of insight. But that's dynamic code analysis, while this is static. So I run these codes. Sorry? It's only the path you run it through. Yeah. I use the Graphis for this. With the dot binary, I can lay out the explanation, run it through it, and create a PNG out of it. And I was thinking this afternoon, where the discussion was also involved about, to generate the other type from the package design for composer packages. But now I'm still whether a composer package would be handy or not. I have done it in the past though. Between objects that are entangled. Yeah, for the package graph as well. How many, if I have this class, how many pieces of our code is it intertwined with, and is it still within its bound of responsibility? And that was really insightful. But yeah, I guess you could also generate them for those. They were pretty easy to generate these kinds of graphs. So yeah. I can understand that you could generate them. Might make something out of that, or look at it if it's already available. But yeah.
I'll be in touch.
Yeah.
I have actually one thing to say. It's not necessarily a question.
Yeah.
And you already said this, but it was very insightful for me.
Mhm.
I attended a workshop, which was, I think, PHP Benelux, from Keith Casey. He does a talk on Fing and Jenkins and also metrics. What was very insightful there was that he said, if you introduce these tools to your project, and this is what you said earlier, don't be scared by the number of warnings you're going to get, or don't be scared by whatever it's going to tell you. The most important thing is that you're looking at it from a more of a relative perspective, where try to improve. It's very useful to know that when you add some code to the code base, does it go up by a lot or does it go down? That's important information. You don't necessarily have to fix all of your previous mistakes, because that's crazy. You can't do that. Definitely not on legacy code base. So that was very insightful for me, because I always thought, oh, okay, yeah, PHP MD. Oh, I got to fix all that. It took me all night, whatever. So yeah, I don't know. Maybe it's useful for someone.
Yeah, we introduced this, and now we have 2 sprints of fixing. Yeah.
Well, yeah. Just
My experience with legacy code is anyway, if you wait long enough, you delete it anyway.
Yeah. The real question is, does it pose a problem to you? If it doesn't, if it works just as,
Depending on how much OCD you have.
yeah. But you could introduce new bug paths because of the empath complexity if you change anything.
You can't say anything because I got the microphone.
Yeah, I know. So, yeah.
Well, thank you.
Yeah, thank you. And a big thanks to these people. Mr. McCabe and Robert C. Martin, also known as Uncle Bob, did a lot of those metrics. And Sebastian Bergman from among PHP Unit wrote a lot of these kinds of tools. Not everything is on here, but a few that I've explained here to use. And they're credits for the insightfulness about applying also the empath in your code coverage, for example, and Xdebug in general. I use it a lot. I'm on everything. I have a join the team page for this event. So if you have any feedback for this talk, like I said, it's try out the first time that I'm doing this talk. Please do so, because I'd like to improve. Thank you.